Okay, hi everyone. I hope you survived lunch. Hope you're ready to take a nap. So let's talk about Java instead. So I have some good and some bad news. I want to talk about Amber and Valhalla and that other stuff. The bad news is I tricked you a little. We're going to talk about that, but that's going to be a little bit towards the end of the talk, because there's something very important that we're going to talk about first, and that's the release schedule and long-term support, so you're up to speed on that. And the good news is we're going to hurry with that, because I'm sure you want to talk about the rest. So we're first going to talk about recent versions and features, just to get a feel of where they come from. And then we're going to talk the new world we're in at the moment, and then we're going to look into the future, to the projects that are coming to Java. Oh yeah, the slides are online at slides.codefx.org if you want to follow along. Let's start with the small story from Java 8 to 12. So who's on Java 8 still? It's like almost all the people, I guess. Great. So it was released in 2014, right? And free support by Oracle ended in January. But if you're still on 8 and you don't want to pay Oracle or anybody else for it, then you can use OpenJDK 8, for which Red Hat will provide support until 2023. And there's even another option that we're going to see later. So the core of Java 8, of course, is lambdas and method references, streams, and default methods. And when that came out, everybody was pretty happy and really psyched that Java finally got a little bit more modern. And but the question is where that came from. Right? It's not like when it came out in 2014, somebody just sat down a few weeks earlier and just typed up Lambda expressions. They were developed over a longer period of time. There was Project Lambda, well named, I would say, which was developed by Brian Getz, and it ran from the end of 2009 all the way to immediately before the release in 2014. And there are a bunch of links here, although if you go to the slides, all the orange ones are links. So there's a project page, there's a Java specification request, a mailing list with thousands and thousands of messages where every big decision and every little detail was discussed to death. And then there were also a couple of interesting talks. One is a linked here, Peek Under the Hood, where Brian Getz explains how Lambda expressions are implemented. And this talk was recorded, I think, immediately after it came out. What I'm trying to tell you here is that what we can learn from that is, before we look at that, let's have a quick look at the evolution of Project Lambda, So when it started in the end of 2019, there was this idea that we want to make functions easier to use in Java. But when it starts with an idea, in this case with a strawman syntax with int x and y there, that looks nothing like what it later ended up being. And over the course of the next couple of years and until the release, that was refined to what we now know as Lambda expressions. So there was an idea, and then there was a first review, and then the second and the third, and things were changed and evolved. And in the end, there was a final ballot only a month before Java 8 was released. So now we're ready to learn something from that. That all these projects, like Project Lambda, they start with an idea that is often conceptually precise, like we want to do this, we want to do functions in Java, but we don't know how yet. We don't know how to implement that. We don't know how that looks in the end. And it can take a long time to get from this idea to the final product that we're using. But as you can tell by the links that I showed you earlier, that process is fairly open or transparent. You can observe that process fairly well. Okay, let's go to Java 9. Who is on Java 9 or later? Wow, that's relatively speaking, that's a lot. I'm proud of you. But you're not on 9, right? Literally, you're on 11, I guess, right? 10. Okay, move to 11 then. So support for Java 9 ended in January. And the core of Java 9 is obviously the module system, but there are tons of other changes in there as well. If you want to learn about the module system, wrote a bunch of blog posts, even wrote a book. But let's talk about where the module system came from. It came from Project Jigsaw like the jigsaw puzzle, right? It was led by Mark Reinhold from Oracle. And it also ran a couple of years, actually a couple of years longer than Lambda expressions. This took about 8, almost 9 years to be done. Once again, there are links. This mailing list, probably even more so than the Lambda mailing list, also tons of discussions about everything. An interesting bit about the module system is that Oracle started talking about that relatively early. So in 2015, a prototype was released, and at Java 1 2015, they gave a lot of talks, starting from very introductory talks like why is there even a module system, what does it try to achieve, down to how are certain things implemented. So these 3 links there, they build on one another. These 3, you can basically look like, 4 links. You can basically look at 4 hours of talks building on one another, teaching a lot about the module system before it was released. Project Jigsaw has a very interesting history, right? So this was when it was announced in 2009. Mark Reinold wrote on his blog, Sun's primary goal in the upcoming JDK 7 release will be to modularize the JDK, which we hope to deliver early in 2010. And nearly everything in that sentence turned out to be wrong. So the first thing that didn't work out was Sun. Then Jigsaw did not make it into 7, but into 9. But 7 was not released in early 2010 either. And then finally, the module system is not just there for the JDK, it's there for everybody. So as you can see, the project evolves quite a lot sometimes. And Jigsaw impacted Java 9 a lot. Originally, it was supposed to be released in 2016, which was 2.5 years after Java 8, or 2 years and a quarter after Java 8. But that didn't really work out that well. So Jigsaw delayed it a couple of times, and then there was a public review ballot in May 2017, and do you remember how that went? Something like this. So it was voted down, actually, and there were a lot of fundamental changes being requested, which is a little bit pointless because there must be a second ballot within 4 weeks, and no fundamental changes can be implemented in 4 weeks. So 4 weeks later, we basically get the same proposal again, one small change really only, and then it passed. So that's a little bit weird, but what we can learn from that there's also some politics involved, and that some of these things, while they evolve, are not actually cordial. Sometimes people fight over big things or over small things. There are lots of heated discussion as well, and you can see that there's a subtext there. Sometimes people on the surface seem to fight about some technical thing, but you can read the mails, the subtext is there, that there's more going on there. But generally, the module system took a lot of feedback into account. That doesn't mean that every single proposal was implemented as the person proposing it actually wanted it to, of course not. But it meant that quite often somebody showed up on the mailing list with a problem, and then what tends to happen is that there's not a lot of feedback there. Not a lot of people from Oracle will reply on the mailing list like, yes, we saw that, we take that into account. It often feels like you're being ignored, but then it happens quite regularly that a couple months later they come out and like, we took you seriously, we looked at that, it's actually a problem, we're doing this. Or we looked at this and we're not changing anything. So the process is not as open as it could be. It's not as easy as you would want to if you give feedback, or to just look up what feedback did other people give. Did somebody already have this problem? Was this already discussed? Searching the mailing lists is not, well, searching them is easy, but finding something on them is not that easy. And we saw that this can take a very long time and delay Java releases. But Java 9 was the last big release. Now we moved to Java 10, released last March, so last year's March, and support already ended, of course. The core of Java 10, you could say, is local variable type inference. There's also application class data sharing. It's not really a core thing, but I like it a lot, so I'll link from it here. If you're interested in your application's launch times, then have a look at that. Also made a video and a blog post about that. And this came from Project Amber. And we'll see Project Amber again on another feature that is already there, and then we're going to look at it once again later, because it's going to bring more features in the future. Let's go to 11. 11 is marked as a long-term support release, but that really only means when Oracle said Java 11 is LTS, what they meant was Java 11 is LTS for people who pay us for that. So Oracle's free support ended in January, so just a couple of weeks ago, but Red Hat picked that up and will provide free support for OpenJDK 11 until 2024. We're going to discuss the difference between OpenJDK and Oracle's JDK later. So Java 11 does not really have a big core feature. It's like, you can do this now. You can actually throw a source file at the JVM and we'll launch that. That's nice, but, well, it's not a big thing exactly. There's a reactive HTTP2 client, another thing that's quite nice but rather small. There's Epsilon GC, which is really small. It's the easiest garbage collector that was ever implemented. It does literally nothing. It just allocates memory. When you run out of memory, it crashes the JVM. And now you might wonder why that garbage collector would exist. And there are actually 2 use cases. I guess there may be even more, but there are 2 big use cases. One of them is if you develop your own garbage collector and you want to compare its overhead, then what do you compare the overhead to? Because all the other garbage collectors also have their individual overhead. But if you compare it to Epsilon GC, then you can actually compare it to 0 overhead. So that's kind of nice. And the other thing is that there are really some people whose program produces so little garbage that they don't want to have a collection ever. They launch the JVM and they run that project however long it takes, program however long it takes, and then they shut off the JVM before there is a collection. And if you do that, then it's nice that you can use a garbage collector which doesn't do anything. These are really awesome, great features in Java 11, right? Not so much. By now we feel a bit like we're being spoon-fed new versions, right? Like there's a new version, next 6 months, new version. You're like, enough already, enough already. So Java 11 contains no language changes, no monumental features that are interesting to developers. But this is not bad. This is the new normal. The old normal was every new Java release contains a bunch of big new things. And the new normal is every new Java release contains a few small changes, and occasionally we see something bigger. And we see the same with 12. The thing that 12 delivered was a preview on switch expressions, which is now being finalized for Java 13, where you can use switch in the context of another statement. So switch it's not its own statement anymore. Instead, switch gets a value here. So you can look at this. Depending on what value day has, the entire switch thingy will then get the value either 6, 7, 8, or 9. And then you can assign that to a variable or return that or pass it as an argument. So this is much like if is a statement, but the conditional operator is an expression, right? You can write return Boolean question mark and then, the thing there. So the conditional operator is an expression, gets evaluated to a value, and the same thing is now true for this switch expression. And then we also get this arrow syntax, which does not have fall through anymore. That's really amazing because I hate break with a passion. Like I use break in, I guess, 95% of the case statements that I write and in a break, unless they have a return. But that's just pointless letters there that just block the view for more interesting stuff. And the arrow form doesn't have fall through. So if you do something there, then it doesn't fall through into the next branch. It's kind of nice. And it's a preparation for upcoming features that we're going to discuss later. Also wrote a blog post and made a video about that. So if you're interested, look through the slide decks. If you're interested in any detail here, there's lots of material being linked. And switch expressions also came from Project Amber. And as I said, we're going to look at that later. So that was the first part. Now we know a little bit about the last features, and particularly what I wanted to stress here is that all of the more interesting ones, particularly the language changes, they all come from a project. There's always something behind that, and we're going to look at those projects a little bit closer later. Now let's discuss where we are right now, because we're not in the same world anymore that we used to live in. In the past, the JDK that you would download from Oracle would be the default for almost everybody. We would just by default go to Oracle's page and download the JDK from there. But that's not the case anymore. OpenJDK is the new default. We used to get new releases every about 3 years, sometimes 2, sometimes 5. The plan was 2 years, but that never worked. Now we get major release every 6 months on time. And in the past, every version that Oracle released, they provided free support until the next version came out, and then another 2 years or something. Free support, that is. And that's not the case either anymore. So that's quite different, and we're going to look at each of the three, why they are that way and what that means for us. So let's start with OpenJDK. What exactly is OpenJDK? Technically, it's the reference implementation for the Java standard. I'm not sure how many other implementations there even are still out there. It's definitely the one that is used by almost all the projects that I know, or all the projects that I know that built on OpenJDK. But technically, it's just a project and a code base. Technically, you cannot download an OpenJDK binary and install it on your machine because the project OpenJDK does not ship binaries. It just contains code. You can clone the Mercurial repository and build it your own, but that's not what most developers want to do. So other people ship binaries built from OpenJDK. And there are two big players worth mentioning. One is Oracle. So Oracle builds OpenJDK and offers it at that URL, jdk.java.net. So when you go there, you get an OpenJDK built by Oracle. I stress that because that is not Oracle JDK. It's just an OpenJDK built by Oracle. And Adopt OpenJDK also builds a bunch of different Java versions routinely. And I think for most people in the future, that will be the place where we get our JDK. For example, my Gentoo Linux that runs on my machine, now they have an OpenJDK repo, so I just get my Java version from there, straight from there. So let's talk about OpenJDK and Oracle JDK. In the past, Sun's and Oracle's JDK, that the one that they was distributing on their homepage, used to contain more features and was perceived as being more stable and more performant. I don't think that was generally true, that they were really considerably more performant or considerably more stable, but they were perceived that way. The idea was, that many people that was my impression surely, and many people that I worked with, that Oracle's JDK was the gold standard, then OpenJDK, it's somewhere down there. But it's really important to note that Oracle and OpenJDK community did a lot of work to align these two code bases. So OpenJDK 11 and Oracle's code base for JDK 11, they are technically identical, except for a few very small details that are hidden behind this asterisk, but that's mostly something to do with certificates, so really, really small things. So Oracle's JDK and OpenJDK are technically interchangeable. That's really important to understand. Now, the difference between the JDK that you will download from JDK JavaNet, the Open JDK that Oracle built, and the Oracle JDK that you can download on oracle.com, whatever, the difference between those really is only the license and the support model. Because Oracle's JDK is fully commercial from 11 on. Whenever you download Java from Oracle's homepage, you cannot use it in production unless you have a contract with Oracle. You can use it in development and in testing, but not in production. And that really makes OpenJDK the new default. That's the reason why I said that earlier. OpenJDK is the new default because you can use it freely. It's the free version, as in for free, it doesn't cost anything, but also the free version because it's GPL licensed with the ClassPass exception. So it's important to get that difference. And that's also the reason why many people were crying that Oracle is making Java commercial and then the world is going to burn, because they saw a small notice on oracle.com's home download page and didn't know that Oracle at the same time offered a free version of the same code, just one homepage over to the left on JDK JavaNet. Okay, so let's talk about the releases. We got that covered, right? We know now why we use OpenJDK in the future, or most of us will, right? There's nothing wrong with paying anybody for support, but I think most people by default use OpenJDK. So let's talk about releases. The old plan was twofold. One half of the plan was we got big flagship features, and once they're done, we're going to release the new version. And the other half of the plan was we have 2 years. And we are software developers. We know that this sounds like there's a conflict hidden there. And of course there's a conflict that never worked out. Java 7 took 5 years. Java 8 took 3 years, although the Java 7 thing also had a lot to do with Sun's problems, not just with the Java. But anyway, Java 8 took 3 years. Java 9 took 3.5 years, mainly because of Jigsaw. So we can see that the 2 years never worked out. And the reason here is mainly psychological, because when you're a developer and somebody tells you, look, are you done by Friday or will we wait 2 more years for your feature? You're more likely going to say, no, I will make it by Friday. And if not, can you give me until next Monday maybe? So that's like the impulse. You don't want to wait for a long time until the next release to get your feature out. And so the decision was always, again, made. There was also the same decision. Okay, let's delay the release for a couple more months until we're done. And then we weren't done. So downsides to that is that a lot of implemented features are done there, they're sitting there in the code base and they provide no value. This is really particularly interesting for Java 9 because many people didn't care about the module system. Maybe they cared about other features that were in there. So now they were waiting because of the module system they didn't care about for something they really wanted. It also means that the JDK team has a harder time to react to changes in the ecosystem because the turnaround time from one release to the next would be like 3 years each, so that takes a long time. And then there's always pressure to be done in time, and nobody's happy with that, right? Management isn't happy, developers aren't happy, we as users aren't happy with that. So there are a bunch of downsides there. So if it hurts, do it more often. The new world is a fixed 6-month release schedule, every March, every September. And everything that is ready by a few months before that, so everything that is ready is shipped, and if it's not ready, it just waits. And bumping something for 6 months is really easy, right? Psychologically speaking, 6 months wait time is close to nothing. The important part here is to point out that while 11 is long-term support and 17 will be long-term support, that does not make them special from a technical point of view. It's not like Java 12 to 16 are just beta versions for 17. That's not the case. All of these have equal technical quality and the same quality assurances. So there's a risk that people start seeing the LTS versions as the real releases and everything else are just minor or beta versions, and that's not true. The difference between 11 and 12 is only that somebody will give you support for 11. So the upsides are basically the inverse of the downsides I mentioned earlier. Now, as soon as the feature is completed, it comes out. There's no pressure to finish anything on time. When it's done, now it's a valuable development strategy, and it's much easier to react to changes in the ecosystem. And we'll see that with incubating features. Because since Java 9, there are incubator modules, which is a way to have an API that is almost done out there so we can experiment with it before it's finalized. Since Java 11 or 12, we also have preview language features, which do the same thing for syntax. The switch expressions I showed you earlier, they were not finalized in 12. The idea is that the JDK team does its best to create a feature that is done for all intents and purposes, but then it will still sit for 6 months, maybe for a year, where we can experiment with it, can give feedback on it, and then it will be finalized. And the other thing, the important thing is here that it's not easy to depend on these incubating features. So there are safeguards there that prevent that everybody starts using the switch expressions and then in Java 13 they change and everything falls apart, right? So you can work around them if you really want to, but you shouldn't. You should use them to experiment, but you should never ship code to customers or to users that depends on that. If it's just your code, then that's your risk. Okay, now let's come to long-term support, and this is more interesting. Let's have a quick look at how exactly the JDK is developed. The URL here points to the Mercurial repository that contains the source code for the OpenJDK. And then there are many clones of that. Each JDK release gets its clone. Each Java project like Amber and Valhalla, they get their clone, and every vendor has their own clone. So there are a bunch of clones out there. But we can simplify that a little bit. We can think of this as one repository with branches. And the way the JDK is developed is really very similar to how we would develop software. So to develop a new feature, there's basically a feature branch. In reality, it's more like a cloned repo that developed that, but conceptually, it's just a feature branch. And when it's done, it gets merged into master. And then for a release, 3 months before the release, and this is where it gets interesting, a release branch is cut. And this release branch, we'll come to that when we talk about long-term support. This release branch is not touched with new features, right? So while there's not yet a release branch for 13. It will be cut in about June, July. There will be a release branch for 13. And from that time on, only bug fixes will land in that branch. The other thing that becomes important for long-term support is how security fixes or bug fixes in general are handled. Usually these fixes are developed on master, right? Assuming that the bug applies to the current code base, then the fix will be developed on master. But then it also needs to be merged in these release branches, right? So let's say Java 11 is long-term support. That means if in a year somebody finds a problem that also exists in Java 11 and the fix is developed on master, then somebody needs to merge that fix to the Java 11 Java 11 release branch. That's what support really means. I mean, technically support means also you get a contract and you can sue someone if something goes wrong, and you can call someone if something goes wrong, but to us developers it doesn't really matter, right? What matters to us is that we will see fixes to bugs that were observed. So what support really means to us is somebody fixes a bug on master and then merges that into the branch for the release that I am using. And now we come to what Oracle really does here. What Oracle does, it says we're developing those fixes not on their own, together with the rest of the community, but they are in charge of developing these fixes, and they do that on master. Now, when they've done that, they will take that fix and they will merge it to the current release branch of the OpenJDK codebase. So the current one would be Java 12. So if a bug is fixed now, it will be merged into the 12 release branch. And when 12.01 comes out in, a couple of weeks, then that fix will be in there. But what Oracle will not do for free in the open is merge that to older release branches. So that's the only thing that's left now. The only thing that's left now is somebody must take a fix that shows up on master and apply it to the JDK 8 release branch or the JDK 11 release branch. That's really all the work that's still needed. And that can range anywhere from trivial, because nothing changed it, so it really just apply a patch in Mercurial. But it can also be very, very complex, because the part that contained the bug in 11 and in the current version might have changed a lot. So the bug might be the same, but the rest of the code might have changed a lot. So that might be real engineering involved to actually get the fix and apply it. And somebody must do that. And you can pay somebody to do that. You can pay Oracle, you can pay IBM and Red Hat, or IBM/Red Hat, because they're all the same. You can pay Azul, and I'm sure there are other people that I don't know about that you can pay as well. And this is what LTS means. Somebody will take these fixes and apply them, and give you a guarantee that if there's a known security problem, you will get a fix within whatever weeks, months the contract says. But we in the Java community are a little bit cheap. we earn good money, but we don't like to spend it. So we would like free long-term support, right? That would be great. And I actually think, money aside, we could spend more on this in general, but money aside, I think there should be free support, because the free version of Java otherwise becomes unusable. And free not only means no money, it also means GPL license and reusable for and independently usable of Oracle, for example, of any other company that might put their fingers on that. So a couple of months ago already, the community at large, the Java community, somehow decided in a chaotic process, not really a process, just like community decided, we want to provide a couple of years of support for all of the versions that Oracle marked as long-term support. We're going to pick the same versions, which is basically random. Everybody could pick different versions. They could say, like, we don't go every 6 versions, we go every 5th version for no reason. But they went with every 6th version. So the idea was, we pick the same versions, and we want to provide support that is long enough to go from one LTS to the next plus 1 year. So about 4 years, that was the goal. And then in the last, it became, I think it started in February actually, but it became public in just the last week that Red Hat will, or the word is guidance. The word guidance is twice there, right? So under Red Hat's guidance, there will be support by the community for OpenJDK until 2023, and OpenJDK 8, and OpenJDK 11 until 2024. And remember, that means they do all this fixing and merging stuff, right? And you can get the builds from Adopt OpenJDK. So that means you can stay on Java 11 until 2024 and get your builds from Adopt OpenJDK, and they will contain the recent bug fixes put there by the community under the guidance of Red Hat. And then there's one other player, and that is Amazon. Amazon said that they're going to provide Corretto, which is a no-cost, multi-platform, production-ready distribution of the OpenJDK. Comes with long-term support that will include performance enhancements and security fixes. So Corretto builds on OpenJDK, but it contains additional security fixes that Amazon and performance fixes that Amazon created themselves, and they said they would like to upstream those changes. So ideally, it would not just be on Amazon's JDK, but also they would show up in OpenJDK, and they will update this quarterly. And they also have, curiously enough, for Java 8, it's the exact same month as Red Hat, and for Java 11, it's just, I think, 2 months difference. So basically pick the same time span for 8 and 11. So now you actually have the choice to pay one of at least 4 companies for support for Java 11, or pick Amazon Corretto, or rely on OpenJDK. So there are a lot of options to choose, and so there's a little bit, I wouldn't call it fear-mongering, but people are saying, now Java is commercial and Oracle broke the Java community, and that's just not true. There are plenty of choice with and without money. But a couple of, I wouldn't call them problems, but a couple of worries remain. That Java will change too fast, the test matrix will explode, the ecosystem will just fragment, and everything will go to shit, basically, just like what happened between Python 2 and 3. I'm here to tell you, don't panic. This is not something we have to worry about. So yes, there will be fast change. No, there will not be faster change. The change will be visibly faster. So the rate of innovation doesn't change. The rate of innovation delivery increases, is what Mark Reinhardt said. So my speed may pick up a little. By and large, the speed stays the same. We just get our stuff steadier, not faster. And Java 10 to 12 show that, because Java 10 to 12 contain in total less features than Java 9, which makes sense, because in total it's just 1.5 years of development time, not 3.5 years. Another thing is that the test matrix will explode if you're compiling your code against Java. If you're having a project that's supposed to run on 5 years worth of Java versions. In the past, that meant 2 Java versions. Now that means, well, up to 10 Java versions. And that's not entirely wrong. Like, yes, that if you don't control on which JVM your project runs, then you will have to do a little bit more testing. And all the tools that are widely used, like IDEs and build tools and CI servers, they support that. I think support could be a little bit better in some cases, but they do support that. Mainly, we really have to get down to how that works. What's the easiest way to find out, oh, the bug only occurs on 11, how do I go into my IDE and switch my build system to 11 to reproduce that bug? We really have to get better at that, I guess. And there's also potential to automate this more. There's a fear this will be like Python 2.3 and the ecosystem will fragment, and that's just not the case. Many of the important projects worked on Java 9 back then. This slide is like a year old. I stole it from Mark Reinhold. He has one for Java 10 and another for Java 11. I'm just way too lazy to copy paste it every time. So the gist is here, all the big projects work, and the smaller projects, many work or are aware of that and are working towards that. So it's not like what happened in the Python ecosystem, that there was really like a chasm there. About migrations, if you move from 8 to 9, you know that could have been tough, depending on the application. Might have been a lot of work. If you're lucky, it couldn't be no work at all. But that is not the norm. Java 10, 11, 12 are all easier than that. So you don't have to worry there. And Oracle is still committed to backwards compatibility, just as in the past. Although, in the tension between compatibility and evolution, we're moving a little bit towards evolution, a little bit out of the corner of just strict compatibility, because deprecations got this new field for removal. And that means that deprecations can actually be removed. That never happened in the past. They were just there, but now they actually get removed. All the guarantees that you got for one major release, well, there's still one major release, right? But the guarantee doesn't hold for like 36 months anymore, but that's 6 months. So that's another change. And then increasing bytecode level can cause some problems, because that usually means that you have to update certain dependencies like bytecode manipulation libraries, and then most likely you have to update the dependencies that use them. So they could cause some update pains, but not a lot. And then finally, if somebody uses incubating features inappropriately, that can also make migrations expensive. But none of those are big risks or big costs. They're just small things that might add up a little bit. So yes, I would say it's a little bit more work than in the past, but the work is steadier. But I actually want to skip that. What I'm trying to say here, you can work around that if you just stick to supported APIs and supported behavior, well-maintained projects. Being very experimental and breaking into internal APIs and using projects that nobody maintains anymore is a little bit more risky than in the past. It was already risky, it got a little bit riskier. The last thing is that a lot of people say that everybody will just stay on Java 11. Nobody will upgrade from there. And I hate to say it, but there is some risk that turns out to be true. So I would love for everybody to just use the most up-to-date version, because it's just the most productive, and frankly, it's also the most fun. But that might not happen because the update from 11 to 12 is a little risky. The question how risky that is depends on your project. The problem here is that once you move to 12, you basically have to make it all the way to 17 without dying, because there's no way to load again. There's no save point on the middle here. There's no free support, or very, very unlikely to be free support for anything between 11 and 17. And even if you pay someone, Azul is the only company that I know that you can pay to get support for versions between 11 and 17. And that means you have to upgrade to each major version as it comes out. Because when you don't upgrade, right, you run an old version of the JVM that has potential security problems. So before you upgrade to Java 12, I want to tell you, read this blog post by Stephen Kerwin, Should You Adopt Java 12? And it basically paints a very bleak picture that this would be hell and don't do it. I would just say take a break and then understand that most of the risks he describes, and the risks are real, but most of the risks he describes only come from when you not only want to run on 12, but you actually want to build against 12. You want to compile Java 12 bytecode, you want to use the new features, your dependencies have to work with that. You don't necessarily have to do that to fix security problems, right? To fix security problems, you just have to run on 12. And then most of the problems disappear. What really remains is, well, deprecations could still bite you. You or your dependencies could use something which is deprecated and being removed. That's one thing, and the other thing is, unsupported APIs that you or your dependencies might also be using can change, particularly unsafe. These problems are not likely because Oracle is continuing to be careful with what they deprecate and what they remove. But for you and me, they might be hard to predict what exactly might bite us in the future, particularly like 3 years into the future. So I would say the chance is low, but unfortunately the damage is potentially enormous. Like if that happens, if you're on Java 14 and you realize you cannot update to 15, then what do? You either run 13 in production, or 14, I don't know what example I just pulled. So either run that old version in production, which if you have a web application is really not a good thing to do, or you downgrade. So you take all your code that you wrote with switch expressions and remove that and move back to Java 11. That would be a horrible thing to do. So that means, like, the expected damage is of course the chance times the damage, right? So the chance is very low, but the damage is So think about this carefully. I don't say don't do it, I'm just saying think about it carefully. In general, the more up-to-date you manage to be, the better this is, because the lower the chance is in general that it will be bitten because you can just update all your dependencies. The fewer dependencies you have, the better. The smaller your code base is, the smaller the damage would be if you actually would have to go back. So if you're doing microservices, for example, then you have a much better chance of just moving with these versions, and if it doesn't work, you go back or you rewrite or whatever microservice people do. If you have a big monolithic code base of like a couple million lines of code, then maybe 11 is the better option for you. So I'm really saying, like, really don't panic. I think this is a good move for the ecosystem as a whole, but not everybody has to keep up with the same speed. It is okay to stay on 11 until you move to 17, but I would still recommend try not to do that. So find a suitable update cadence for your project, and specifically look at the specifics of your project. Don't let anybody tell you do X or do Y. Look at your project. But whatever you decide, I recommend to build on each release. As soon as 12, 13, 14 come out, build on those releases so that you can be safe regarding the future. You know that a change is coming that causes some problems. You can probably already react to that, and you can particularly prevent piling more problems on that same change. If you know that a particular API is removed in 13, then you do not spend 2 more years at using that API before you move to 17 eventually. As I said earlier, only rely on standardized behavior. There's a tool called JDepreScan, which tells you what is deprecated. So that's the absolute minimum that you should do. Run that from the most recent Java version, and it tells you what you're using that you shouldn't be. And then in general, it's very easy to say and not always easy to do. The more up-to-date your dependencies and tools are, the easier all of this will get. But most importantly, and finally, be aware of what's coming in the future. And that's what we're going to look at now. I think I'm going to cut a couple minutes into your break, if you're interested. Let's have a look at what's coming. But we will not focus on versions, because nobody knows what's going to be in Java 14 or Java 13. As I said earlier, these features are developed in projects. Some of the smaller ones are developed in so-called JEPs, which is Java Enhancement Proposals. And those are the interesting things. We should look at that. And we should keep those names in our mind. It's less interesting what will be in Java 16. It's more interesting of what is Project Valhalla doing. And we're going to look at that, and you're going to see a lot of syntax. And all of that syntax is made up, mostly by Oracle, partially by myself, because it's easier to explain. So if you don't like the syntax, never mind. This is not final, right? It's just to get a feeling for what's coming. Bunch of interesting projects. We're going to start with Project Amber. It's focused on smaller productivity-oriented Java language features. It's led by Brian Getz. And as before, there are a bunch of sources that you can look at, and there are a lot of talks already. There are unofficial early access builds. It was never as easy to look at what's coming in Java as it was today. You can go anywhere from, I'm just going to look at the project page every couple of weeks, to I subscribe to a mailing list and try to read what's going on, to I try this actually out and give feedback. You can do whatever you want. It's really easy to get into it. It was launched in March 2017. It's just 2 years old and already delivered a couple of things. And the motivation here is it tries to make Java less cumbersome, less verbose, and improve expressiveness. That's what Amber is here for. And already delivered var in Java 10 and switch expressions in 12. And there are a couple more things, a lot more things actually that it wants to do. Pattern matching, records. There's a consideration of revamping serialization from the ground up. Concise method bodies are kind of interesting. And then also raw and multi-line string literals. So let's have a look at pattern matching. We saw switch expressions earlier. Switch expressions had the property of we have this arrow which doesn't have fall through, and the whole switch gets a value that you can assign. What pattern matching starts to build on top of that is we want to have a more powerful case, basically. The old times case was only compare to a value. Is that the same value? And now we will get new things. This case statement, for example, can match types. Is value of type integer? Is it of type string? And if it is, you get a new variable called, in this case for string it's called s. You get a new variable that is typed as a string, and you can use it as a string. If you call s.length, for example, you can do that. So you get more powerful conditions and less repetition between the condition and the block in this case, because you don't have to cast. In the past, you would have said, if value instance of string, then cast value to string, do something string specific. You don't have to do that casting anymore. The next step from there will be so-called deconstruction. the case statement will be able to look into the values of an instance, and you can take it apart. So here I built a very, very small concept of you have nodes, and these nodes can be evaluated. And there are small arithmetic tree here where you can add stuff and negate stuff. And you could do this with polymorphism, of course, but this is how you would do it with pattern matching. You can say if n, the node n, if that's an integer node, then the result will be the number that's in there. And we extract the number I from inside that node and then reuse it, in this case to return it. If it's a negation node, then if we evaluate that node and the result, we just negate that. And if it's an addition node, we evaluate both of the nodes and then add them together. So you can see that we go into that instance and take the values out. And then, of course, begs the question, like, wait, how does that work? Like, how would the compiler know what the value is? How can we deconstruct this thing? This is where records come in. Another new thing, not only made for this, but suits this very well, where the compiler will generate a lot of stuff for you. So Amber aims at giving you records. These are not the same as values or value types, right? You have to keep that apart. I will talk about that later. This record is a range from low to high, and the idea here is the compiler will generate the stuff for you. Constructor, getters, maybe setters, equals, hash code to string, all of that. The compiler will do all of that based on low and high. And of course, today you would have your IDE generate that. But then if you add a new field, you have to remember to edit everywhere. So this will be much easier for maintenance. But it's not only there to save you time while coding, it also makes Java more expressive, because now you can express this range thing. It doesn't really encapsulate anything. It's just basically a small wrapper around two other values. So you can express more clearly that this is it does not contain a lot of business logic. The deal here is that the API for record models, the state, the whole state, and nothing but the state. You give up encapsulation, and you couple the external API to your internal state, which usually we don't want to do, but still we have a lot of beans which do exactly that, and you get the API for free. And I'm sure like somewhere between 10 and 30 or 40% of the classes in many code bases are really records hiding to come out. We will most likely be able to customize records. Here the constructor, public range, this is a constructor, also contains a conditional check to make sure that high is actually not lower than low. And you can also, if you have setters somehow, you can also interact there. It's not clear how, but there will be capabilities for that, so you can customize those. Another thing that is targeted is the death for serialization, because serialization is horrible. It's not great to use exactly, but if you ever listen to the JDK architects and how they work on JDK, they will always say serialization complicates all the work they're doing. Whatever feature they're doing, and yes, this even includes lambda expressions and that kind of stuff, we would not expect to have any interaction with serialization. Every time serialization pops up sooner or later, and it's always a hassle. And the reason for that is that it uses these invisible mechanisms that are really specific to this purpose and very hard to generalize over. It was a repeated reason for security vulnerabilities. It's a big problem. The JDK team wants to get rid of it. And the idea is the things we want to serialize are probably the same things that don't distinguish between the API and the internals. Records seem to be a sweet spot for something you want to serialize. So the replacement may look something like this, and this is a very, very vague plan. It's not even a plan, it's just an idea. The new serialization thing would only work on records. You could give it a graph of records and would start to deconstruct that, and then would pass the value to some serialization engine. And that serialization engine could then write XML, JSON, YAML, whatever. And deserialization would then work the other way around. So as I said, I think records are a great fit for that, and the new method would use these deconstructors for records that the switch expression, for example, uses as well. And this would make, I think, our code more maintainable, but also the JDK, particularly the JDK, more maintainable. Another neat feature, I'm just slapping you with feature ideas here. Another one is the idea of concise method bodies. Sometimes you just want to forward a method call. Why not make that easier? Wouldn't that be nice? If you want to call size on my list wrapper, I just forward to the thing that I wrap and call size there. If you do it like this, like usually when you have like curly braces, and then I would usually put empty lines between my methods. I think that's normal for most people. If you pull them all on one line, I would even be okay with getting rid of the empty lines. And this makes it really easy to see, oh, they're just a bunch of forwards. And then maybe further down you will see, or further up, I don't know, wherever, you will see some actual methods that do something. So you should see Amber's features, and none of them are huge, but they all have the same direction. They all try to add something conceptually simple to make it easier and more expressive to use the language. And then finally we had raw string literals. Raw string literals, the idea is that you start a string maybe with a backslash, nobody knows yet how that could look, and inside that string, no escaping. Everything is just the way it is. You don't need to escape anything. So it's great for particularly for paths and for regular expressions, of course. Because regular expressions are a real pain when you write them in Java, right? Like, there are not enough backslashes already. Now you also have to add the extra backslash that you need for Java. It also makes it really harder to copy-paste. You cannot just copy-paste the regex from Stack Overflow because you have to add all the backslashes, right? So this way you could just backslash, quotation mark, just paste the regular expression in there, you're done. We could also get multi-line string literals, maybe starting with 3 quotes, where you just can type multiple lines. And within that, you can not only have multiple lines, but you can also use the single quotation mark because it's not special anymore. For example, like here to quote the content. Particularly if you write JSON that use a lot of quotation marks. And then most likely we will be able to combine those somehow. Also, nobody knows how. Because the thing is, this was a preview feature for Java 12. It was already merged. And then in December, so like 2 weeks before the deadline, it was pulled out because apparently it's more complicated than everybody thought. So this is now on the back burner. It's not even scheduled for 13. It's still being worked on. And there's a lot of interesting discussions on that as well. Like the mailing lists are treasure trove. And you always look at this and you think, that's simple, right? Like, why don't you just do that? But if you look at these discussions, the amount of thought that goes into that is incredible. So in summary, Project Amber aims at making Java more expressive. Type inference and switch expressions, we already have that. And then we had a bunch of other things over the course of the next releases. And we will see them step by step. Pattern matching is a great example where the new release cadence comes in. In the past, there would have been just the entire pattern matching would have dropped in one release after like 5 years of development. And now we'll see that in small steps. And each step can check, did that work out? And if a part didn't work out, maybe the next part of the feature looks different. Okay, officially I'm done with my time. Do you want to stay for another 5 to 10 minutes to look at Valhalla? I see people nodding. Okay, let's do that then. So Valhalla aims at advanced Java language feature candidates, which I find really weird because that's very, very general. Once again, tons of links. For this, we even have official early access builds, and I can only invite you to try them out. This launched in July 2014, so it gets 5 years old soon. This is a complex problem. The basic motivation is that in Java, almost everything is a class, and it has a bunch of disadvantages. Everything in the class is mutable by default. You have the memory access indirection of, well, this is a string, but it doesn't really contain anything. It's just a pointer to memory location, and then the characters are in that memory location. So you always have that indirection. And you have an extra memory for the header, because the pointer that points to the thing down there, that takes memory. But also the thing down there has a header that denotes which instance it is. So for example, that is used for locking. That is basically what distinguishes one instance from another, how the two equal signs distinguish two elements. So there's a lot of stuff there that you need for identity-based operations, but if you don't care about identity, then all of that is just stuff that clogs up your memory. It would be really nice to have your own custom int, maybe like a complex number, for example, is a great example, or the range again. So this looks similar to what there was before, but it's not the same. Let's go look at this and then compare it to records later. So here the idea is, I want to have a range, but this range really isn't really a class, it's a value. It has these two fields, low and high, and then I have to write constructors and whatever I need, and equals and hash code, all of that I would have to write myself. But what I get here is enforced immutability. You can never change a value type, just like you cannot change a small int. There's a small int 5, and if you add 1 to it, you get a new small int that's 6. You don't change 5 to 6. You don't get memory indirection. There is no pointer to the range. the content is right here, right now. So that makes the memory flat. Flat, let's say you think of an array of strings, then you really have an array of pointers pointing all over your memory. If you have an array of values, then the values are right there. That's why it's called flat. And it's called dense because you lose the object header. This header is only there to store identity-based information. And these things don't have identity, just like it doesn't make sense to distinguish one small int 5 from another small int 5. They're the same thing. A range from 0 to 5 is a range from 0 to 5. And another range from 0 to 5, well, that doesn't make sense. There's no other range. It's the same range. But once again, also, it makes Java more expressive because you can now express this thing is just a value. It's not defined by its behavior. It's not mutable. It's just a value. The goal here is codes like a class, so you can extend interfaces, you can write methods, you can encapsulate internals, but it works like an int in practice when it comes to memory layout and performance particularly. And the deal here is you give up identity and mutability and something else I'm not going to go into, and as in exchange you get a dense and flat memory layout. So this is another deal, right? This is no identity and mutability, but I get flat and dense memory. And records said, I don't want encapsulation, I want to get less boilerplate. So while they look similar, they're not the same. Actually, they're quite different when it comes to what the deal with the JVM here is. But I guess there will be a fair chance that very, very many of them actually need to be both or prefer to be both. So there most likely will be a way to have value records or record values, so to just, not type anything and get all the great performance. And then this comes together with something else, because at the moment primitives are boxed, right? A list of int doesn't exist. You have to have a list of integer, and then the list of integer is backed by an integer array, which means it points all over the place. That's barely acceptable the way it is now. But if everybody starts creating values, and as soon as generics are involved, they get boxed, you cannot code without generics, really. So you would lose the value of primitives, of records immediately. No, of values. You'd lose the value of values immediately. So we need to be able to have a list of our range. That means we also have to be able to have a list of int. And that is actually being worked on. That's the major challenge that Project Valhalla faces at the moment, or works on at the moment. We want to have an array list of int that is actually backed by an int array. And if that were the case, then you get a great performance boost, just, for example, for the collections, for free, basically. And then this would also work with our value types. And if you put them together, then it has immense effects on the JDK itself. The stream API and the option API contain a lot of manual specializations, right? You know that there's an in stream and a long stream and a double stream. And the reason why they exist is because otherwise there are a ton of things that you couldn't do with streams, because a stream over integer is really, really slow compared to an in stream. So somebody at Oracle sat down, and I really don't envy them, to actually implement the same code, but put, instead of the generic T that stream has, put an int everywhere. Basically, that's it. And the goal would be, if that worked, then all that code could be thrown away, because now a stream over int is exactly the same as what an int stream used to be. That would be the goal. It's not clear whether that can be reached. And the JDK would just have better performance on many, many different levels. And the same applies to our code. We have to make fewer trade-offs between design and performance. For example, let's say you develop a game and you need points. So what you would do today, you would start with a point class that has X, Y, and Z coordinates. And then you'd find out when the game runs that you're creating millions of points. You're just clogging up your garbage collection. Everything falls to pieces. So then you go back and, okay, I just have 3 arrays, 1 X coordinates, 1 Y, and then I just kind of simulate classes around that. That is horrible. That's a bad design, but it's, well, bad. It suits the purpose, right? But it's not good, easy to read and maintain, and it's only that way because of performance. And with value types, this conflict would largely go away. You could do what you want to do and get great performance. And the last one, more robust APIs. Imagine APIs only communicating with immutable objects with other APIs. Wouldn't that be awesome? No way to pass something that then somebody over there changes and everything fails. So this is what Project Valhalla does. I'm not going to keep you longer. I have some slides here for Project Loom. Have a look at the slide deck, which is somewhere. Oh yeah, that's last slide, sorry. Pick a project that interests you. I showed you 2. There are way more. Look at them. Look out for something on social media that mentions them. Maybe subscribe to the mailing list. Find the early access builds. It's never been as easy to have a look at what Java is developing, and also to give feedback on that, to get valuable feedback on that. And now I'm done. Thank you very much for staying here much longer than you were supposed to. I hope you had a good time. If you have questions, you can just come up to me now or see me around the conference. I'll be here the rest of the day, and then have a lot of fun with the next talks.